A reading of zero resistance between phase A and phase B bus bars in a newly installed main panel indicates a serious problem that needs immediate attention. Several possible causes can contribute to this issue. Firstly, a bus bar short circuit could be the culprit. This occurs when there is a physical connection between the phase A and phase B bus bars, creating a direct path for current flow. Secondly, panel miswiring can unintentionally connect phase A and phase B together. Incorrect wiring within the panel could lead to this unintended connection. Thirdly, defective cable insulation can cause the issue. Insulation damage between phase A and phase B cables allows current to flow through the insulation. Fourthly, although less likely, an inaccurate or damaged meter could provide false readings. It is crucial to verify the meter's functionality using a known resistance before assuming a fault within the panel. The primary concern when encountering zero resistance between phases is safety. Immediately turn off the power to the panel and disconnect the power source. This step is crucial to prevent further damage and potential injury. Maintain a safe distance of at least 10 feet away from the panel and ensure others are clear of the area. Do not attempt to inspect or repair the panel while it is energized, as this could result in electrocution. Contact a licensed electrician to diagnose and repair the issue to ensure the safety of the building and its occupants. Attempting to troubleshoot or repair such a fault without proper training and equipment can be extremely dangerous. The electrician will systematically investigate each potential cause, starting with a visual inspection of the bus bars for any obvious physical connections or damage. They will then use appropriate testing equipment to verify the integrity of the wiring and insulation. Once the cause is identified, they will take the necessary steps to correct the fault and ensure the panel is safe to energize. These steps may include replacing damaged components, correcting miswiring, or improving insulation. After the repairs are completed, the electrician will thoroughly test the panel to ensure that it is functioning correctly and that there are no remaining safety hazards. This testing may include voltage measurements, insulation resistance tests, and ground fault impedance measurements. In addition to the immediate safety concerns, a short circuit between phases can cause significant damage to electrical equipment. The high current flow can overheat conductors and damage insulation, potentially leading to fires. It can also damage connected appliances and equipment. Therefore, it is essential to address the issue promptly to prevent further damage and ensure the long-term reliability of the electrical system. When working with electrical systems, it is crucial to follow all applicable safety regulations and codes. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and using properly rated tools and equipment. It is also essential to have a thorough understanding of electrical principles and safe work practices. If you are not qualified to work on electrical systems, it is always best to call a licensed electrician. Electrical work can be dangerous, and it is not worth risking your safety or the safety of others. For large services with multiple parallel conductors, it is especially important to ensure proper termination and insulation of all conductors. Loose connections or damaged insulation can create hot spots and lead to short circuits. Regularly inspect all electrical connections and insulation for signs of wear or damage and repair any problems promptly. In addition to the potential causes already mentioned, other factors can contribute to short circuits in electrical panels. These factors include moisture, corrosion, and physical damage. Moisture can reduce the insulation resistance of electrical components, making them more susceptible to short circuits. Corrosion can damage conductors and connections, increasing their resistance and generating heat. Physical damage can compromise insulation and create direct paths for current flow. To prevent these problems, it is essential to keep electrical panels clean and dry and to protect them from physical damage. Regularly inspect panels for signs of moisture, corrosion, or damage and take corrective action as needed. Another important consideration is the proper grounding of electrical systems. Grounding provides a path for fault current to flow back to the source, tripping circuit breakers or fuses and preventing electrical shock hazards. Ensure that all electrical panels and equipment are properly grounded according to applicable codes and standards. Regularly inspect grounding connections for corrosion or damage and repair any problems promptly. The use of appropriate overcurrent protection devices is also essential for electrical safety. Circuit breakers and fuses are designed to interrupt the flow of current in the event of a short circuit or overload, preventing damage to equipment and reducing the risk of fire. Ensure that all electrical circuits are protected by properly sized circuit breakers or fuses. Do not replace circuit breakers or fuses with high-rated devices, as this can overload the circuit and create a fire hazard. Regularly test circuit breakers to ensure that they are functioning correctly. In addition to the specific issue of zero resistance between phases, there are several other general safety precautions to keep in mind when working with electrical systems. Always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized before touching any conductors. Never work on energized circuits unless you are qualified to do so and have the proper personal protective equipment. Be aware of the potential for arc flash hazards. Arc flash is a dangerous electrical explosion that can occur when working on energized equipment. Wear appropriate arc-rated clothing and personal protective equipment when working near energized equipment. Follow all applicable safety regulations and codes. Electrical work is regulated by a variety of codes and standards, such as the National Electrical Code or NEC, that are designed to ensure safety. Be familiar with these codes and standards and follow them carefully. If you are unsure about any aspect of electrical work, consult a qualified electrician. It is always better to be safe than sorry when it comes to electricity. In conclusion, a reading of zero resistance between phase A and phase B bus bars in a newly installed main panel indicates a serious problem that needs immediate attention. The potential causes include a bus bar short circuit, panel miswiring, defective cable insulation, and meter malfunction. The primary concern is safety. Immediately turn off the power to the panel, maintain a safe distance, and contact a licensed electrician to diagnose and repair the issue. By following these precautions, you can protect yourself and others from electrical hazards and ensure the safe and reliable operation of your electrical system. Here are some additional details to consider regarding the 6 parallel feeds of 500 kcmil cables per phase. Firstly, ensure that all 6 cables in each phase are properly terminated and torqued to the manufacturer's specifications. Loose connections can create resistance and heat, leading to potential failures. Secondly, verify that the cables are properly supported and protected from physical damage. Cables that are not adequately supported can sag and strain the connections, while physical damage can compromise the insulation and create short circuits. Thirdly, check that the cables are properly sized for the load they are carrying. Undersized cables can overheat and fail, while oversized cables can be unnecessarily expensive. The ampacity of 500 kcmil copper cable depends on the insulation type and installation conditions, but it is typically around 380 to 430 amps per cable. With 6 parallel cables per phase, the total ampacity per phase would be between 2280 and 2580 amps. Ensure that the panel and service equipment are rated to handle this amount of current. Fourthly, confirm that the cables are properly identified and labeled. Proper labeling makes it easier to troubleshoot and maintain the system in the future. Fifthly, inspect the cable insulation for any signs of damage or deterioration. Damaged insulation can create short circuits and ground faults. Finally, consider using a cable management system to organize and support the cables. A well-designed cable management system can improve the appearance of the installation and make it easier to access and maintain the cables. Regarding the grounding system, ensure that the grounding electrode conductor is properly sized and connected to a grounding electrode system that meets the requirements of the NEC. The grounding electrode system typically consists of 1 or more ground rods, ground plates, or connections to a metallic water pipe. The purpose of the grounding electrode system is to provide a low impedance path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Regularly inspect the grounding connections for corrosion or damage and repair any problems promptly. In addition to the grounding electrode system, it is also important to bond all metallic enclosures and equipment to the grounding system. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electrical shock. Use appropriate bonding jumpers and connectors to bond all metallic enclosures and equipment to the grounding system. Inspect bonding connections for corrosion or damage and repair any problems promptly. When working with large electrical services, it is also important to consider the potential for harmonic currents. Harmonic currents are non-sinusoidal currents that can be generated by electronic equipment such as computers, variable frequency drives, and LED lighting. Harmonic currents can cause overheating of conductors and equipment, as well as voltage distortion and other problems. If harmonic currents are a concern, consider using harmonic filters or other mitigation techniques to reduce their impact. Finally, document all electrical work that is performed. Keep accurate records of all wiring changes, equipment installations, and test results. This documentation can be valuable for troubleshooting and maintenance purposes. It is also important to comply with all applicable permitting and inspection requirements. Electrical work typically requires a permit from the local building department, and it must be inspected by a qualified electrical inspector to ensure that it meets the requirements of the NEC. Following these guidelines will help to ensure the safety and reliability of the electrical system. Remember, electrical work can be dangerous, and it is always best to consult a qualified electrician if you have any questions or concerns. The electrician will have the knowledge and experience to perform the work safely and correctly. Do not attempt to do electrical work yourself unless you are qualified to do so.